So you've done degree 1 equations, which just have an x and a y, and the y is never has a power on it, which really means it's to the first power. And the x has a first power on it. And at the beginning, you never even thought about the powers. It was just x. Okay. But then we went up to just the unit we just finished, which was x squared. So take a wild guess what happens next. Yes, we get up to the x to the thirds and the fourths and the fifths. So this is third degree equations. You've probably heard of third degree burns. Well, the degree is like the bigger the number, the bigger the degree. Okay, and it's a first degree burn is just like, I'm sure there's official definitions for these things, but it's really, really gentle. It's not that big of a deal. It'll heal up, no big deal. And there's second degree. And third degree are really, really, really serious. I had a friend who was, he knew that this gas can was about to explode by a fireplace. And he threw the gas can away from the fire. And of course, that gas dripped on his arm, which then caught on fire, and he got to have third degree burns on his arm. And so third degree equations aren't like especially scary or anything, but that's degree. All right. So it's the biggest power that's there. That's the degree. Okay. So this is a third degree equation. And fourth and fifth and sixth, there's just as easy as you think. If I put a 13 here, then that'd be the 13th degree equation. All right. Now I want you to copy down just one big equation like this, and I'm going to tell you a whole bunch of stuff about it. You know I don't ask you to take like serious notes on everything I say, but this one sheet full of information is really important. All right, negative 3x to the fifth plus 4x to the third plus 2x squared plus 1. Now, to be able to talk about these equations, we have to have some common language. And so one of the things that you have to understand is the word for each of those little blocks. Each of those little blocks is called a term. How many terms do I have? In this case, I have 4. Even the 1 counts as a number of terms. So underneath this is where we're going to write the terminology, term. Everybody write that. It's got 4. It's a 4-term equation. All right, what's another word that I've mentioned that hadn't mentioned much before today and I've mentioned like 3 times? There's the D. Degree. Is this degree 4 because it's got 4 terms? No. It's degree 5 because that's the biggest power that any of the variables have. All right. Next thing you have to know is the number at the end is different than all the other numbers because it doesn't have an X on it. There's a name for it. It starts with a C. Anybody know the name for that? To be able to talk about these things, we have to have a common language. Constant, very good. Constant. And the constant in this case is 1. It's the number at the end. I think you're going to know this one because I gave you a definition that would last. Finish this sentence for me. The y-intercept is where? X equals 0. Good. So what's the y-intercept on this problem? If you stick in x equals 0, what do you have left? 1. The y-intercept is 1. But we always write our y-intercepts with the x equals 0 built right into it. All right, that's 4 things about this. We're not even close to done. There's so many more things you have to know. All right, the next one is called the lead term. Now, the leader isn't always in the front. Do you know that during the Vietnam War, they would shoot at the officers. They would try to get the officers, because once you got the officer in the group, then the rest of the guys didn't have a leader anymore, and it made it way harder for them. So they would try to, for a while, the officers were always leading, and then it was easy. You just get the guy in the front, and then that was the leader, and then it would be, that was their goal, was to take out the officers. All right. Well, that meant that they needed to stop having the officer be in the front all the time. Okay? And so different people would take point. Now this right here, that 3x to the 5th, it happens to have the biggest power, and it happens to also be in front. Even if it wasn't in front, it would still be the lead term. Whatever's got the biggest degree, that's the lead, even if it's not in front. Okay? So in this case, it is in front, but I just didn't want you to think that it's the lead term because it's in front. It's the lead term because it has the biggest degree. All right, so that's the lead term. There's another term that we have to know, and it's called the lead coefficient. We're going to abbreviate that lead co, C-O-E. Anyone want to take a shot at it? Say it if you know it. All right, then you're learning something. It's the number in front of the lead term. So it's just the -3. The lead coefficient. The coefficient is a number in front of a variable. Right? Is there more than one coefficient up here? Yeah. The -3 is a coefficient. The 4 is a coefficient. The 2 is a coefficient. The 1 is not a coefficient because it's instead called a constant. All right. These are important terms. We're going to use them a lot this unit. This is called the higher degree polynomials unit. And basically, we're moving on from the biggest degree was squared pretty much before this. And now we're going to degree 3, degree 4, degree 5. All right. The next thing you have to know from this same problem would be what happens on the right end. What we're talking about here is not the one that's on the right end of the equation. It's if you graphed it, what would be happening to the equation on the right end? So I'll show you a little picture for this. We already know it has to hit +1 as its y-intercept. So there'll be a dot like right there. Okay? But is it going to go up as you go to the right, or is it going to go down as you go to the right? Anybody have a theory? Yes. You are correct. What was your guess based on? -3. Yes. The lead coefficient being negative. If it's negative, that's telling you it's going to go down on the right. So right end, down. But don't just say down. You got to say why. Why is it going down? Because, that's going to be a abbreviation for because. Down cause, why? It's cause lead co is neg. The right end will go down because that number right there is a negative. All right. Is there anything else? Well, if we just did the right end, you probably figure we're going to do the left end. Yes?
Would there ever be like a reason, like another reason why it would go down and it's not negative?
If this is not negative, as in if it is positive, it will always be going up. And if that number is negative, it'll always be going down. It's that simple. No, nothing else that happens in the rest of the equation would change that. I think that's what you're asking. It's just an always thing. Okay, so the right end was down because the lead coefficient is negative. All right, this is the last thing you have to write. The left end. For these notes today, this is the last thing. The left end, we're going to not talk about up or down. We're going to talk about, is the left end going to be the same or different than the other end? So if I'm sketching this little graph out, so far I have a y-intercept of 1, and I know it's going down because the lead coefficient is negative. That means this side of the graph is going to go down. The other side of the graph is either going to be the same as that, going down, or different than that, which should be going up. Okay, so anybody want to have a theory on this one? Yes?
The exact opposite.
You think it's going to be different? Tell me why, though. This is important. What about this equation makes you think that the other end will be going different? All right. Your gut was right, but you didn't know why it was going to be different. So I'll explain. It will be different. You're right. So in other words, it'll be going up on the left. Why? Because the degree is odd. Any degree you have will either be odd or it'll be even. So this one's different because the degree is odd. That's a lot of notes. But if you wrote them all down, now you have a chance that if you're in your homework and you're like, oh, okay, I can't tell if this thing's going up or down on the right or up or down on the left. Or I don't know what this lead coefficient thing is. You have one good shining example. All right. So now I want to run through a few and let's see if you get what they're going to look like. Now this graph, I don't know what it's doing in the middle, but I do know that it has to go through that point right there, and it has to be going up on the left and down on the right. So for right now, that's good enough. If you needed to know exactly where it goes, of course, a graphing calculator would tell you exactly. And I told you a long time ago that your XY chart, if you graph enough points, and you figure out there's a point here, 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 you'll be able to connect all the dots and know exactly where it goes. So you could put in 0 and you'd get 1 because, you know, if x is 0, you're doing the y-intercept, right? And that's 0, 1. And if I wanted to put in 1, that'd be pretty easy. I just stick in a 1 where all the x's are, and I could figure out what my answer comes out to be. And I could stick in 2 and 3, and I could stick in -2 and -3, and I find a bunch of dots. But for right now, this is good enough. You know that it's going down on the right. Why again? Because that was negative. It's going the opposite way on the left because it has an odd degree. All right. So let's see if you really process this. Here's a new one. It's going to be completely different. 6x to the 5th minus 2x to the third plus x plus 7. Some people say kind of a mean thing about Minnesota. They say that Minnesota's flyover country. There's not that many people that live in the Midwest. And on the coasts, there's a lot more people. And so, for instance, they'll say in California alone, there's 55 million people. There's only 5 million people in that whole Minnesota, okay? And you add in North Dakota and South Dakota, you're probably only up to like 6 million. And again, there's 55 million just in California. So why am I talking about flyover country? Because this whole thing in the middle doesn't tell us anything. It doesn't tell us whether it's going up or down on the left or the right. It doesn't tell us the y-intercept. It's kind of useless info. Now, sure, it would help you if you were finding an XY chart and you wanted to find a bunch of points. But other than that, it doesn't tell us much. It's all about that lead term, the degree, which is on the lead term, and the y-intercept. So the beginning and the end are important, and the stuff in the middle really doesn't have much. Okay, so for this, you should be able to answer a gajillion questions about it. Here's number 1. What's the lead coefficient? Number 2. How many terms did this thing have? Number 3. What's the right end doing? It's either up or down. That's all you have to say. Not rising and falling, it's just up or down. Number 4. Is the left end the same or different? And number 5, what's the y-intercept? You should be able to answer all those questions about this from what I taught you. I'll pause for a second while you try to answer 1, 2, 3, 4, and 5. Okay, the lead coefficient on this one was, just because it's in front, is it guaranteed to be the leader? No. It's because it had the biggest power. So that is 6. The terms, 1, 2, 3, 4. The constant counts, so 4 terms. Right end. You don't look at the right end of this, you look at the beginning of this. Since that lead term, the lead coefficient is positive, it's up. The left end tells you whether you'll know if it's the same or different on the left end. And it's that 5 right there. And since it's odd, it's different. So it's not up, it's down. And the y-intercept is just 7, but you can't just say 7. The y-intercepts are x equals 0, 0, 7. All right. Who had all of those right? Excellent. Okay. Then the only thing left is what if they try to confuse you with something like this? Don't even write it down, just look. So what's the curveball in here? I know somebody sees it. Yeah.
The number or the term with the biggest power is not in the front.
Yes. So all of a sudden, even though that's way back there in position 3, it's the third term, it's actually the lead term. Why? Because it's got the biggest degree. Okay? So then if they asked, is it going up or down on the right side, you'd look here. And since it's got a negative there, it's going down on the right. Could you move it to the front? Sure, you could, but you're not required to. All right. Y-intercept's still 4. Would the left end be the same or different? Are you looking there? Because if that's odd, they'll be different. Okay. All right. And then the last thing they can do to kind of confuse you on these is to make them factored. Now if they ask you what the lead term is, you will be a little confused because you're like, what is the lead? So what you have to do is in your head, just multiply out and figure out what the lead term would be. Would you agree it would be bigger than just x? Would you agree it'd be bigger than x squared? Could you believe it would be x to the third? It is. Try to figure out why. Do you get, by multiplying this part out, you'd end up with an x squared, and then you times by what x one more time, and you'd end up with x to the third, see? Now remember how I said there was flyover country? I don't care about the rest of the equation, because it doesn't tell me much. Then the last thing I need is the y-intercept. Finish this sentence for me. The y-intercept, which goes right here, is where x equals what? 0. So you'd put a 0 here and a 0 here, and you'd go 3 squared is 9 times 2 makes 18. You get how you can get the beginning and the end? And that's all you need. So now I can tell you that this one goes up on the right, because it's positive in the front. It goes down on the left, because it must be going the opposite direction, because it's odd degrees. And that tells you it's going to go the other way. Up on the right, down on the left, and it goes through the y-intercept of 18. All right, cool. So here's a typical question. They give you this. And they ask, what's the lead? Well, there's lead coefficient and lead term. What's the lead term? You got to multiply it out in your head. Would you agree with 2x squared? Okay. Then, what's the degree of this thing? It's 2, because that's the biggest power. Notice there was no squareds anywhere, but I knew that I had to multiply it out first, and then I'd get my degree is the biggest power that I have, which is that. And since that's positive, it'll be going up on the right. Since that's even, they'll be going the same direction. So if it was up on the right, it's also up on the left. All right, cool. So you now have a Schoology quiz. Last hour I had literally had 0 questions, which was impressive. I think I must have explained it well enough, but I really hope that somebody in here comes up and asks me a question, because I honestly was wondering what was going on. So please come up if you get stuck. I'll happily help you. And I promised that I would not give you your scores, but I kind of lied in that I'm going to tell you your score, but only your score on the cumulative. And I'm not going to be able to give you time to look at it and see what you did wrong. We don't have enough time. And I still have other tests to grade to be able to get my 3rd hour back. These take forever to grade because they're twice as long as a normal test. So to be able to get them their scores at all, I cannot talk over your score. I can show you your score. Would you agree seeing your score is better than no score? All right, so I'll show you your score. Please don't ask me to say why, what was wrong. I'll show you that on Monday. Okay, but at least you get your score back today. All right, that's all I got for you for today.